Hello everyone, a very warm welcome to this video. In this video, we are going to talk about what exactly is Hadoop. So let's start with what is Hadoop. In the most simplistic terms, Hadoop is set of machines that are out there to do your job. So you first dump your data, it will store it in a distributed fashion, and then you submit your program and your program will run in a distributed way. In more simplistic terms, Hadoop is a framework that facilitates functioning of several machines together to achieve the goal of analyzing large sets of data. The first company that created a system like this was Google. Now, Google created its own distributed system and they gave away 2 white papers. Now, based on the white papers, duck cutting from the community took those white papers and created this system called as Hadoop. Core Hadoop consists of 2 components, HDFS and MapReduce. A set of machines running HDFS and MapReduce is known as a Hadoop cluster. Individual machines are known as node, and a cluster can be as small as a single machine to as big as thousands of machines. In the most simplistic terms, the easiest way to visualize Hadoop would be Hadoop is set of machines that's running your job, and it takes all your big data and provides you 2 services, processing and storage, gives you processing and storage. Now, how do you go about visualizing Hadoop? If you really look at it, Hadoop is a normal master and slave configuration. So you have a master and you have slaves. On the master for the storage, the services that runs is called as name node, and the service that runs on the master for processing is job tracker. On the slave side, the service that runs for storage is data node, and the service that runs for MapReduce or processing is task tracker. So the entire flow is from your laptop, you will first, from your client basically, you will first dump your data and then you will dump your program. So when you dump your data gets broken into pieces of 128 MB in the latest version, and previously it was 64 MB, and it would be spread across the cluster with a replication factor of 3. So if you give a file of 512 MB, it will be cut into pieces of 128 MB, that will be 4 pieces, multiply by 3 will be 12 pieces, 3 is a replication factor that can be configured. After you've done your data ingestion, you will submit your program, and your program would basically run on each and every local machine and process the data. So just to summarize it, data is broken into file splits of 64 to 128 MB, and the blocks are moved on different nodes. Once all the blocks are moved, Hadoop framework passes the program to each node. Job tracker then schedules the program on individual nodes, and once all the nodes are done, the output is written back. Now let's understand this with a lot of examples. So let's take this scenario. So we are a bank, and today we have received 900 million likes on Facebook. What we want to do is get a report that gives country-wise likes. So what we do is we have some data where we've got 900 million likes. We've got that data from Facebook. What we want to do is we want to figure out from each country how many people have liked our Facebook page. And let's say we want to use Hadoop for this. So the way it would look is you would have a master and you would have slaves. Now here you will have on the master name node and job tracker. On the slaves you will have data node and you will have task trackers. Now when you ingest data, let's say your data is Facebook likes dot log, and that's 512 MB. Each block would be 128 MB and it will be replicated 3 times. So data is spread and totally there will be 12 blocks. And the name node metadata would look like Facebook likes dot log is nothing but BLK001 to 004. BLK001 is present on slave 123. BLK002 is present on slave 234. BLK003 is present on slave 2, 3 and 4, 235. BLK004 is present on 1, 4 and 5. So that is how your distribution would look like. So this is name node's metadata. Name node would randomly put data on certain blocks and this is the metadata. After that, you will submit your program that will basically do the country-wise likes. So I would say this is country-wise likes.jar file. We will submit this jar and this jar gets submitted to all the slaves. And because there are 4 blocks, job tracker will choose any 4 machines to process the data. So job tracker would decide BLK001 should be processed on machine number 1, BLK002 should be processed on slave 2, BLK003 should be processed on machine 3 and BLK004 should be processed on machine number 4. That is something that's decided by the job tracker and the processing happens. That's exactly how Hadoop would work. So you first give your data, gets cut into pieces, gets distributed with a replication factor of 3 and then you submit your code would work and these preferences are decided based on locality. That is how Hadoop really works. So a quick summary of Hadoop would be Hadoop is storage plus processing, gives us 2 services, storage plus processing, and when you talk of storage, the name of the team that gives you storage is called as HDFS and the name of the team that gives you processing is called as MapReduce. And to expand, storage is HDFS where the master is name node and data node, and processing is MapReduce, which is job tracker and task tracker. So the overall flow is step 1, data has to be ingested. Step 2, when data is ingested, the data gets broken into blocks of 128 MB and replicated across cluster. Step 3, Name node stores the metadata. Step 4, code is submitted by the user to the job tracker. Step 5, job tracker decides which slave will process which block based on data locality. Network use is discouraged. Step 6, each block is processed and output is consolidated. That's exactly how Hadoop works. Now, the biggest, this is called as Hadoop 1.x, and the biggest issue with Hadoop 1.x is it only accepts MapReduce jobs. So let's take a scenario. If I write a library that would basically do processing of connections between people, and if that does not use MapReduce, technically I could not use Hadoop at all. So if somebody had to use Hadoop, the only option that was available was writing MapReduce code. There was no other way to write your code. Now this was seen as a serious limitation, and that's why the developers of Hadoop came up with the next version of Hadoop that's called as Hadoop 2.x. Now let's look at how does Hadoop 2.x work and how is it different. So in the previous case, we had name node, data node, job tracker, task tracker. Now in this case, job tracker was a bottleneck because job tracker only knew MapReduce. To solve that issue, job tracker, task tracker was replaced by resource manager and node manager. Now let's understand what was the benefit of it. So job tracker and task tracker was replaced by resource manager and node manager. Now with resource manager and node manager, there was no processing logic at all, and a developer was free to set up app masters, one for MapReduce, and other frameworks were also welcome. So that way the processing framework now became like a plugin, So first data would be ingested, broken into blocks. So that process remains same. But when it came to processing, when the job was submitted to resource manager would call the app master, and app master was supposed to execute the job. How that exactly works, that will be covered in the later videos, but it was app master that was responsible for executing the job. So this was Hadoop 2.x. Now just to quickly summarize, the easiest way to visualize Hadoop 1.x and 2.x would be in 1.x it was HDFS and MapReduce was on top of it. In 2.x it's HDFS, it's yarn, and MapReduce was just one of the framework. This was 1.x, this is 2.x. In the most simplistic terms, in 1.x MapReduce was the only way. In 2.x, MapReduce is one of the way. So that kind of clarifies how 2.x is different. And let's put that in plain mathematics, that will help. So Hadoop 2.x is actually about storage, processing, and resource management. If you break it down, storage is HDFS, which is name node and data node. Processing would be MapReduce or any other framework, and resource management team was called as yarn, which is actually resource manager and node manager. So this is Hadoop 2.x. Just to summarize, in 1.x, MapReduce was the only way. In 2.x, MapReduce is one of the way. So that brings us to the discussion of what exactly is Hadoop 1.x and what exactly is 2.x. Now, as we said, Hadoop is about HDFS, MapReduce, and yarn. So in the next section here, we are going to talk about, we've understood Hadoop, but how does HDFS work, how does MapReduce work, and how does yarn work? So let's get going to what exactly is HDFS. So let's quickly decide what next it is. We have Hadoop 2.x, which is HDFS, yarn, and MapReduce. Let's take each topic separately. We say HDFS, it's a storage system. Yarn, which is a resource management system. And MapReduce is one of the processing engine. Okay. So now the next topic that we are going to talk about is HDFS, and HDFS is a storage engine. HDFS is a set of machines that is responsible for storing data on a cluster of machines. So let's talk about what exactly is HDFS. For Hadoop to be able to process the files will have to be in HDFS first. That's Hadoop's own file system. HDFS is responsible for storing data on cluster of machines. Data is normally split into blocks of 64 or 128 MB, and that's absolutely configurable. By default, each block is replicated with a replication factor of 3, but the replication factor can be increased or decreased based on your configuration. And to ensure data is not lost, HDFS is smart enough to not place same blocks on the same machine. A bit more on HDFS. It's a file system that's based on Google's GFS, operates on top of native Unix file system, provides replicated storage of data using cheap commodity hardware. One reason Hadoop still does not have a real competitor in the market is because the cost per terabyte that Hadoop provides is the cheapest, because the slaves that you use in Hadoop are really cheap. They are also called as commodity hardware, typically also called as white boxes. So you don't have to go to a big time vendor and buy expensive hardware for Hadoop. HDFS file system is read-only, random writes are not allowed. Very important. Hadoop is a file system where you can't change the data. Once data is dumped, you can delete it, but you can't update the data. And it's the name node and data node process that takes care of HDFS. For HDFS to be accessible, name node has to be up all the time, because name node is the brain of the system. So how does HDFS look like? You have a master node and slave node. On the master, you are running name node. On the slaves, you are running data node. Okay, and the data is basically distributed. So that is HDFS. Let's understand HDFS with some more detail. So let's take a case. Today we purchased 1000 machines of 8 terabyte each hard disk. Is it really possible to store 2 petabytes on any one machine? That's not really possible. So we have 1000 machines. And each machine has a capacity of 8 terabytes. And it's not possible to store 2 petabytes. But what if we set up an entity like a name node where each machine is willing to give 6 terabyte of its storage? So each machine will give 6 terabyte of its storage as HDFS storage. And suddenly the name node can cater up to 6 petabyte of storage. So the point is, HDFS in this case is a virtual file system with a capacity of 6 petabyte. So to summarize, 2 core points. First point, HDFS sits on top of Unix file system. Second, HDFS has its own file structure. So folders of HDFS are not accessible from Unix file commands. So in this example, there are 2 file systems. On each machine there is Linux file system, and HDFS is a separate file system of 6 petabyte that will have its own storage, its own folder structure. That is how you look at HDFS. So HDFS is nothing but a lot of machines coming and giving their storage, and Hadoop cluster adds up everything and shows you that big resource where you can store the data. That's how Hadoop is able to store a lot of data. So this is how HDFS works. Now let's basically talk about, okay, we are clear with Hadoop, we are clear with how HDFS works and data is being distributed, but how do you really process this data? Data is broken into pieces, we are supposed to process it, but how does this processing work? And that's where we'll get into our next topic, which is called as MapReduce. So let's talk of what exactly is MapReduce. MapReduce is the data processing component of Hadoop. It attains the task of processing by distributing tasks across the nodes. Task on each node processes data locally, it tries its best to process data locally. Consists of two phases, map phase and reduce phase, and in between map and reduce phase there is a phase called as shuffle and sort. So let's talk about it. Assume we have a file that has some text and it's named as data.txt. Now the goal is to count the number of times each word occurs. So let's say this is the data we have. Hi, how are you? Where have you been these days? Where can I find you and are you there? Now what we are trying to do is we are trying to count the number of times each word occurs. So our final output, expected output is hi one, how one, R2, U4 and so on and so forth. In MapReduce, each key is or each record is viewed as key value pair. In this case, line number or the byte offset is our key and the value is the entire line. So we have 4 key value pairs here, 1 comma hi how are you and so on and so forth. We have 4 key value pairs. Now let's say this was a very big file and it was 512 MB. It would be cut into 4 blocks and there would be 4 mappers running. Now the map function reads one record at a time and the output that you get is hi one, how one, R1, U1, so on and so forth. Once you have all the mappers done, there is a massive shuffle and sort phase where all the data comes together. And that's where you have stuff like R11, bean1, can1, days1 and so on, so forth. In the reduce phase, you would add everything up and you get your final output, that is word count. So let's understand MapReduce with some more detail. Let's understand MapReduce with some more detail. So let's say there are 4 employees. Now these 4 employees are supposed to work on every Saturday and they are supposed to submit a report. Saturday being a weekend, they decide that let's work from morning 8 to 10 o'clock and at 10 o'clock one guy will stay back and consolidate the whole thing. So every Saturday let's come to office at 8. So John, David, Jack and Daryl all 4 are in office at 8. From 8 to 10 they work and at 10 o'clock one guy will stay back and consolidate the whole thing. So let's take this case. This Saturday, if all 4 are in office, it's morning 8, 9, 10. At 10 o'clock, they decide that this week, David is supposed to stay back. So after everybody is done, they will submit their output to David. So let's quickly summarize. From 8 to 10, when everybody is working, that's called as map phase, where each mapper minds its own business. So from 8 o'clock to 10 o'clock, every employee was focused on its own work. That's mapper phase. At 10 o'clock, when all the output is passed to David, that is called as shuffle. That phase is called as shuffle phase. Now, all the output is with David. Before David starts doing anything, David will basically group it together and that phase is called as sort. What exactly is sort? The next example will cover that. And finally, David will give the output. So in a nutshell, so far, MapReduce looks to be some way of divide and conquer. Some way of divide and conquer. In the next example, we'll get more clarity. So watch out for the next example. So in the next example, let's take we have 800 students. We have 800 students and all 800 students are either from California or from Texas or from Michigan or from Washington. So we have 800 students. They are either from California, Texas, Michigan or Washington. What we want to do is we want to count the number of students from each state. So let's say this students file, take an example, this students file is 512 MB. So that logically means there will be 4 blocks. Now each mapper is supposed to process one block, but the way map function works is map function will read one record at a time. So map function will read one record at a time, and the output from map may look like CA comma 1, CA comma 1, Texas comma 1, and so on and so forth. It can't have CA comma 2 because map can see only one record at a time. So we have all the 4 mappers giving us output. At this moment we decide that there will be one reducer. So everybody pushes its output to that reducer. So suddenly the reducer machine now has 800 records. And this phase of passing output to the reducer is called as shuffle. In the sort phase, the machine actually ends up creating 4 buckets. It will be CA comma 1 1 1 1 1. Why? Because there are totally 4 states. And in the reducer takes one bucket at a time and gives output as that looks something like this. That is how your MapReduce really works. Now, a tough part to understand would be how are we getting these 4 buckets? The easiest way to visualize this is if we look this whole problem as a SQL problem, we could easily say that this is nothing but select state comma count of star from students table group by state. And if you run this query with the same data, you would get 4 records as output. And that's precisely what you get here. So post the sort phase, all the unique items are brought together and their values are with that. And that's how bags are created. This is exactly how MapReduce works. It's divide and conquer. So now that we are clear with MapReduce, so we've understood one phase of Hadoop, which is HDFS. We've understood another phase of Hadoop, which is MapReduce. The third phase of Hadoop that we are going to talk about is yarn. So looks like HDFS is storing the data, MapReduce is processing framework, but how are the resources given away? Let's talk about that. And that is done by yarn. So how does yarn really work? So here we have master and slaves. Okay, and MR app master is installed on every machine. So first the data is given to name node, and the name node basically passes the data. We've already seen that. When you give code to resource manager will basically initiate an app master and initialize it on one of the slaves. The MR app master will then ask for resources from the resource manager, and resource manager will grant those resources. once the resources are given, the app master will basically run the job on each and every slaves. So the responsibility of execution is with MR app master. So in this slide, what we see is that this is how Yarn would give you resources. Now, what we've actually covered is we've covered what is Hadoop, HDFS, MapReduce, and Yarn. We've covered MapReduce, HDFS, and Yarn. Now let's look at how failures are handled, why Hadoop is better, and then we can conclude this video. So let's go on. So looks like the entire Hadoop process is you first submit your data that gets cut into pieces, and then you submit your program and the program gets scheduled and the job is done. Let's quickly talk about the fact that in the previous video we saw that the first level of distributed system which had centralized storage was awesome, but Hadoop is better than that because there were 5 problems in the first system, that is a centralized storage. Let's see how Hadoop is better than the centralized SAN system. So in the previous generation system, we saw that there were 5 problems. Huge dependency on network, scaling up and scaling down was not a smooth process, partial failures were difficult to handle, a lot of processing power was spent on transporting data, and data synchronization was required. Let's see how does Hadoop solve problem of huge dependency on network. In Hadoop's case, data does not travel to processing, but it's the processing that's traveling to data, and that's why the network is not a big issue. Previously, data was central and data would travel to the processing. Here, data is already distributed and the processing is traveling. That's why the network utilization is not as huge as previous generation systems. Scaling up and scaling down was not a smooth process in previous generation system, but in Hadoop it's very smooth because nodes in Hadoop virtually don't talk to each other. That implies that nodes need not know what other nodes are doing. As each node performs its job in near isolation, scaling up and scaling down was absolutely not an issue. Talking of the third problem, in previous generation systems, partial failures were difficult to handle. But in Hadoop, it's not that difficult because one, there is replication. So as nodes work in near isolation, if a node goes down, it does not have impact on other nodes because it's isolated. We have replication factor also. And if a node goes down, the job tracker or the app master will basically schedule the job on some other machine. Fourth, a lot of processing power is spent on transporting data. Well, in Hadoop's case, data is only transported once. After that, the processing gets transported towards the data. And the fifth point is, in previous generation systems, data synchronization was required during exchange. But in Hadoop, each node operates on its own data without any communication. That's why you don't need any synchronization. Everybody works in isolation. So this is where Hadoop is better than the previous generation system where you had a centralized SAN. Let's quickly talk about failures. How are failures handled in Hadoop? The task is sending a heartbeat to the task tracker that everything is fine. The task tracker is sending a heartbeat to a job tracker that everything is fine. Any task that throws an exception or fails to respond is considered to be failed. The job tracker or the app master reschedules the job on some other machine. If a task fails 4 times, the entire job is failed. So as soon as 4 tasks have failed in a job, the entire job would be suspended, and you are supposed to submit the job after submitting the or fixing the issues. So that brings us to the end of this particular video. In this video, what we've seen is, we've seen what is Hadoop, we've seen what is HDFS, how HDFS works, we've seen what is MapReduce, how MapReduce works, we've seen how Yarn works, how Hadoop handles failures, and why Hadoop has an edge over other distributed systems. So that was all about what exactly is Hadoop. Thanks for watching this video and see you in the next video. Thank you.